Hello friends, today in this PPT we will be studying about Unit 1 Basics of Measurement. In that lecture 3, it is from the subject Electronic Measurement and Instrumentation. So let's begin with the contents. So what we will be studying first, statistical analysis, then arithmetic mean and deviation, then next one average and standard deviation, then limiting and probable errors, then variance, and last summary about it. Okay, so first one we will be seeing about statistical analysis. So statistical analysis of measurement is a procedure of collection, analysis, interpretation, presentation and organization of data. Okay, so here you can see it is depicted in the form of figure. You can see what all we will be doing in statistical analysis, that is random errors are generally an accumulation of a number of effects due to unknown causes. Such errors are normally small. The only way to minimize random errors is by increasing the number of readings and using statistical methods. So statistical analysis allows analytical determination of final result in the presence of random errors. Okay, so here to make statistical analysis meaningful, a large number of measurements are required. So systematic errors should be small compared to random errors, because statistical treatment of data cannot remove fixed errors. So one disadvantage, it cannot remove fixed errors. Then next, arithmetic mean. Okay, so arithmetic mean is what? Sum of readings. It is the divided by number of readings. So here you can see where in the diagram you can see here x bar is equal to x1 plus x2 plus x3 dash dash till xn, that is nothing but sum of readings divided by number of readings, that is n. Okay, so where this x1 x2 till xn is nothing but readings of samples taken, then n is the number of readings. Okay, and x bar is nothing but your arithmetic mean. Okay, so x bar is the symbol for your arithmetic mean. The next one, deviation. So deviation is the departure of the given readings from the arithmetic mean of the group of readings. So here you can see that is nothing but d1 is equal to x1 minus x bar, d2 is x2 minus x bar, that is still dn xn minus x bar. Okay, so where dn is nothing but deviation of the nth reading, xn is nothing but nth reading, x bar is nothing but your arithmetic mean. Okay, so here you can see in the this average and standard deviation. So average deviation indicates the precision of the instrument. So it is the ratio of sum of absolute values of the deviations to the number of readings. So the expression you can see here, d bar is equal to average deviation is equal to nothing but absolute value of the deviation divided by total number of readings. The equation you can see over there. The next one is standard deviation. So this, it is nothing but statistical analysis of random errors. The root mean square deviation or standard deviation is very helpful over here. So here the standard deviation also called as mean square deviation. Okay, so n is nothing but number of data is defined as the square root of the sum of individual deviation, that is divided by the number of readings. So it is nothing but your square root of what? Sum of individual deviation squared divided by the number of readings, n. You can see in the this equation, you can see that equation. The next one, limiting and probable errors. So here limiting errors. So in limiting errors, what it is? They are used to indicate the accuracy of an instrument. These limiting errors, they are used for indicate the accuracy of an instrument. They are given by the manufacturer to define the maximum limit of the error that may occur in the instrument. The next one is probable errors. So this probable errors, it is defined as the half range of an interval about a central point for the distribution. then such that half of the values of the distribution will lie within the interval and half outside. So probable error will be nothing but 0.675x. Okay, x into standard deviation. Okay, then next one, you can see over here probable error what it will be in the diagram. Okay, in that range it will be. Then next one, so here in probable error what it will be, in your probable error, this one, the number of readings of the same quantity are taken at a small time interval, okay, and they are then next tabulated in this. The most probable value of the true reading is the central value or the mean reading. So the central value will be your probable, okay, as shown in the diagram. Then next one, variance. So what is this variance? So variance, thus it is nothing but it is the square of the standard deviation is called as the variance. Variance, or it is also called as mean square deviation, is the same as the standard deviation except that the square root is not extracted. Variance, it is expressed as V, that is standard deviation square. So you can see here V is equal to standard deviation square, it is the formula. Then what we have studied in this summary, here in this lecture we have studied about statistical analysis, that is we can minimize the random errors by increasing the number of readings. Then statistical analysis allows analytical determination of final results. Variance is a convenient quantity because variance are additive. Thank you.